Welcome to Module 7, Lesson 2, Solving Problems with proportions.
Today we're going to talk about how to create proportions and how to use proportions to solve real-world problems involving unit pricing and constant speed. Alright, so we went over some vocabulary terms, so make sure that you went over those vocabulary terms before we go through this. So first we're going to talk about Sheldon and Leonard. And they were partners in a business, and Sheldon makes $2 in profits for every 5 that Leonard makes. So he makes 2 for every 5. So you know right off the bat that this is a ratio, okay? Because 2 for every, you know that's ratio language. And if Leonard makes 20 in profit on the first item they sell, how much profit does Sheldon make? So our question in this case, my highlighter was really big there. There we go. So my question is, how much profit does Sheldon make? Well, let's take a look here. Does it matter that they went into business together? Does it matter that they went into business together?
No.
All right, so we're going to go ahead and cross that out. But does it matter that Sheldon makes $2 for every $5 that Leonard makes?
Yes.
All right, so right now I have to go ahead and look and box my important numbers. In this case, my important numbers would be 2, okay, for every 5, and then that Leonard makes 20, okay, and then what I need to check out here is that and I need to make sure that I notice what goes with what. So I'm actually going to use my highlighter again here, and I'm going to notice that Sheldon goes with the 2, and then that 5 goes with Leonard, and that in this case Leonard gets the 20. Okay, and the first thing that I'm going to do is I'm actually going to set up my first ratio. So I'm going to not shut up because of Sheldon, I'm going to set up a ratio of Sheldon's profit to Leonard's profit because it's already set up for me. It's 2 to 5. Okay, but I'm actually going to set that up as a proportion because I know a proportion is a ratio, 2 ratios set up as an equation. In this case, it's 2 to 5 is equal to something to 20 because I know that the ratio is 2 to 5, and that's going to be equal to something to 20. Now 20 has to be set up across from the 5 because 20 is how much Leonard makes. All right, and I don't know how much Sheldon makes, so the x, my variable, has to be set up across from what we know about Sheldon. So I have to keep my labels set up across from each other, just like we were talking about before when we talked about just ratios. We have to keep everything lined up nice and neat. Same thing when we take those ratios and put them together to make a proportion. You'll notice that just because we use these different words doesn't mean that the way that they work changes. So now I took this use common denominators to write equivalent ratios. I think that wording sounds funny. Honestly, what you're doing is you're just saying, okay, well, what I did was I multiplied 5 by 4 to get 20. So I know my golden rule is what I do to one, I have to
do to the other.
Yep, because that's the golden rule. So I have to multiply the top by 4. So I know that if Leonard is getting $20, so if he's getting times 4, then Sheldon has to get times 4. Okay? So then what that tells me is Sheldon's profit will be $8 if Leonard makes $20. Again, it's that same idea. It's that same process. Before, when we were working with just ratios, when it wasn't called a proportion, we knew that in order to find this missing number, I had to look at it and go, okay, well, I multiplied by 4, so what I did to the bottom, I have to do to the top. That process doesn't change just because now we're calling it a proportion. Okay, so now you have a your turn problem. I want you to make sure to do your ride, right? And then when you come back, we'll check your answer. All right, so you should have found that you highlighted how many cheese pizzas will they order. If they order 15 pepperoni pizzas, you should have boxed your important numbers being 15 and then 2 for every 3. And then important words in this case. For every. Honestly, I would have circled for every because that honestly tells me that I'm going to be setting up a ratio. All right. And then I would, if you don't have something to indicate with colors, you can do cheese and then underline pepperoni and pepperoni. And then how many cheese. So then when you look down here, I showed you my work. I had cheese listed on top and pepperoni listed on bottom. I knew that to figure out my pepperoni, so to go from 3 to 15, I had to multiply by 5. So what I did to the bottom, I had to
do to the top.
And so when I multiplied 2 by 5, I got
10.
So I had to get 10 cheese pizzas. Right? All right, so now we have Allie, and she is running. And Allie runs 36 minutes. And we see that on her pedometer over here. And we want to know at this rate, how far could she run in 60 minutes? Well, notice it doesn't give us all the information written in the problem. We have to use information from the picture. So in this case, she ran for 36 minutes, which is important. Okay, so 36 minutes is important. Okay, and we want to know how far she could go in 60 minutes. But then now, we know that from the picture, she ran 3 miles. So sometimes not all the information is in the question. Sometimes it's given in the form of the picture. So we have to look over here to get some of our information. So the first thing that we're going to do is we're going to set up our proportion. All right, so here our proportion is going to be set up in terms of minutes and miles. So when I think about rate of speed, it's always distance over time. So the distance that she went was, we're going to do time over distance in this case. So she ran for 36 minutes and she went 3 miles. And I want to know then, if she ran for 60 minutes, how many miles would she go? Okay, so that's what the question is asking me. And what I should have done here was I should have put my labels, which I forgot to do ahead of time. So I'm going to write those in now so I make sure that I have them correct. So I had minutes on top, so I'm going to put minutes, and I have to just double check. Okay, so I had 36 minutes on top and 3 miles on bottom. So I had 60 minutes on top, which means what I'm looking for is miles. And so at this rate, how far could she run? So let's see, how far could she run tells me that I'd be looking for miles, which in this case is the missing piece. So I did set up my proportion correctly. So far, so good. Now the thing is, does this lend itself nicely to figure out the answer? Do I know what I multiplied 36 by to get 60? Not necessarily. Could I figure it out? Absolutely I could. That doesn't always mean that that's what I have to do. What I could do is I could break it down and find my unit rate, because 36 and 3 are both divisible by 3. So what I can do is I can say, well, 36 and 3 are both divisible by 3. So as a unit rate, I know that Allie runs 12 minutes to go 1 mile. So she runs for 12 minutes and she'll go 1 mile. So knowing this, I can set it up and say, okay, well, if I know this, I can set up a new proportion and say, well, if she goes for 12 minutes and runs 1 mile, what does that mean in terms of running 60 minutes? How many miles will she go? Well, I know that to go from 12 to 60, I have to multiply by
5.
and what I do to the top, I have to
Do the bottom.
so on the bottom, I have to multiply by
5.
and when I do that, I get
5.
so now I know that when she runs for 60 minutes, because that's what's on top, because we always had minutes on top, that she will run 5 miles. So then in this case, I know that my answer is, at this rate, Allie can run 5 miles in 60 minutes. All right, so now what I would like you to do is I'd like you to take this opportunity to do the your turn, do your ride. Okay, and now for this one, again, it's not going to work out so nicely, so I want you to practice using the unit rate to help you solve the problem. When you come back, we'll check your answer. Okay, in this case, you should have gotten 108 minutes. So each station runs for an equal amount of time. If it takes 48 minutes for the first 4 stations to water, how long does it take to water all parts of her lawn? So that was the question. How long does it take to water all parts of her lawn? And we know that there were, oops, sorry, wrong button. We want to know, so there were 9 stations. And it's 48 minutes for 4 stations. And that's how long, so it took 48 minutes for the first 4 stations. And there are 9 total stations. So what we can do is we can set up our rate so far. So it was 48 minutes over 4 stations. I could reduce that to get 12 minutes per station. I could then multiply that 12 minutes and by one, or that 12 minutes per 1 station by 9 stations, and I would get 108 minutes for 9 stations. Now we're going to take this and we're going to take it one step further, and we're going to tie it into social studies and talk about maps. Okay, my map got cut off a little bit here, but you should still see the full map in your notebooks. All right. The distance between 2 schools on Lehigh Avenue is shown on your map, and we want to know what is the actual distance between the 2 schools. So in this case, what is the actual distance between the 2 schools? You'll notice there is no actual number information in this problem. All the important information in terms of numbers is actually given in the picture. All right, so let's take a look at this. This is where we're talking about scale and scale drawings. So we have to look here. We know that the distance between the 2 schools is going to be important. And here, the distance between the 2 schools is shown right here. And it is actually 3 inches. Okay, but then now, how do I know, how is that going to help me? Because it's obviously not 3 inches between the 2 schools in real life, because we would step on both schools anytime we took a step. But when I look down here, I see this lovely thing called a scale. That means in our picture, anytime we measure 1 inch, in real life, it actually equals 2 miles. Because if we made a map that was actually as big as our actual world, can you imagine how much we would have to fold a map? I can barely fold my map as it is. So now take it and make it actually as big as our world actually is, and oh my goodness, I would be completely lost. So what we would do here is we would set up another proportion. One side of the proportion would be the ratio of our scale. All right, so first it would be our scale, which is 1 inch to every 2 miles. So for every 1 inch on the map, it's 2 miles in the real world. But then on our map right here, we measured how many inches?
3.
That's right. We measured 3 inches. So are we going to put that on top or are we going to put that on bottom?
Top.
We're going to put that on top because on top is where we put the inches in this case. And we are looking for the actual distance, and we know the actual distance in this case is being measured in miles. All right? So then once again, we're going to use our math and figure out that to go from 1 inch to 3 inches, we multiplied by
3.
3. And I know that rule. That rule is what I do to the top, I have to
do to the bottom.
All right, and since I multiplied by 3 on the top, I have to multiply by 3 on the bottom. So what that tells me is, if it's 3 times the distance on the map, it's 3 times the distance in real life. So in real life, it is 6 miles from one school to the other. So that tells me the actual distance between the schools is 6 miles. Can you imagine having a map in your car that was 6 miles wide? Oh my goodness, that would be huge. All right, so now it's your turn. You are going to take this lovely map here with these crazy names, and you are going to use the scale and the distance, and you are going to figure out the actual distance between the 2 towns. When you come back, we'll check your answer. All right, so you should have found that the scale was 1 inch. So there's 1 inch on the map for every 20 miles in real life. And on the map between Sandville and Lewiston, there's 2.5 inches. So in real life, so to go from 1 inch to 2.5 inches, you multiply by 2.5. So to go from 20 to X, you have to multiply by 2.5, which gave you 50 miles. All right, so what you're going to do is you are going to do your guided practice. I am not going to put numbers 1 and 2 on the guided practice because that's just too many boxes and too confusing to be filling in on the guided practice. However, 3 through 9 are going to be on there, so please make sure to enter those in. And as always, if you have any questions, please be sure to write them down or email me so we can go over them in class.
Deuces.